In this video, we're going to take a look at rational exponents, which connect very closely to radicals that we've been working with the last few days. A rational exponent is when you have an exponent that looks like a fraction. So our example here, we have a to the 1 over n power. That can be rewritten as the nth root. So a rational exponent is the same thing as a radical. In our second example, if the numerator is not 1, it's another number, a to the m over n power. The m stays as a power, and the n is still the root. So an easy way to remember that is the denominator, what you're dividing by, is the root. The power, the numerator, stays a power. It can also be rewritten with the power on the outside because you can multiply in any order, which is our power of a power rule. We're going to start off by evaluating some powers. Our first example is 144 to the 1/2 power. The 1/2 power I want you to, at some point this year, think of immediately without rewriting it as a square root. This is something that I want you to know the same way that you know 3 times 4 is 12. You don't have to think about it. You don't have to do that repeated addition. You just know it because you're so familiar with it and you've used it so much. I also want you to get to that point with the 1/2 power, that you look at a 1/2 power and you just know that it's a square root because you're so familiar with it. The square root of 144 is 12. Negative 125 to the 2/3 power. When you're evaluating a power that has a numerator and a denominator, the denominator is the root. The root will make the number smaller, where the power will make the number bigger. So when you are doing this without a calculator, which you will be expected to do, take the root first, because who knows what 125 squared is? That's most definitely not something that I expect you to memorize, but you should know the cube root of 125, and then we'll take that to the second power. Cube root of negative 125 is negative 5, and negative 5 squared is 25. Next, we have negative 16 to the 5/4 power. Notice this time that that negative is not grouped with the 16. This is an order of operations issue that a lot of students struggle with, because we see a negative number as being one entity. Order of operations sees a negative sign as multiplication by -1. Well, multiplication comes after exponents in order of operations. So the last thing that we will do on this one is throw the negative sign on our answer after we multiply by -1. The first thing we will do is evaluate that rational exponent, that 5/4 power. So I'm going to leave the negative sign on the outside of the root for that reason. The 16 goes on the inside, and the power of 5 will go after we take the root. The 4th root of 16 is 2. 2 to the 4th power is 16. Again, we will take that exponent. 2 to the 5th power is 32. And then we'll multiply that 32 by a -1. Finally, we have 64 to the negative 1/3 power. Remember, a negative exponent means flip it. So this becomes 1 over the cube root of 64. So I both evaluated that negative exponent by flipping it and changed the 1/3 power to a root. The third root, or the cube root of 64, is 4. 4 to the 3rd power is 64. All of those exponent rules we learned still apply to rational exponents. We just have to work with fractions instead of integers. I will start by squaring before I multiply. I'm going to leave my 8x to the 2/3 power alone. Squaring both the 3 as well as the variable piece. 3 squared is 9. And when we have power to a power, we multiply those exponents. 2/5 times 2 is 4/5. And then we'll multiply our expressions together. 8 times 9 is 72. And when we multiply powers, we add the exponents. So we have to take 2/3 and add it to 4/5. Of course, we need a common denominator when we add fractions. Our common denominator is 15. For our first fraction, we multiplied by 5. Whatever we do to the denominator, we do to the numerator. Our second fraction, we multiplied by 3. So we have 10/15 plus 12/15, which gives us a total of 22/15 for our power. Example B, we're going to distribute that power, that negative 1/2 power in the numerator, and then we'll simplify with that w in the denominator. 4 to the negative 1/2 power, we're going to evaluate that in a minute, and then our power of a power rule is multiply 4/3 times 1/2 times negative 1/2. I like to cancel before I multiply. 2 goes into 4 twice, so we have negative 2/3 as the simplest form of our power over w to the 3/7. Both of those pieces in the numerator have a negative exponent, so I'm going to flip them to the denominator. We get 4 to the positive 1/2, w to the positive 2/3, and w to the 3/7 that was in the denominator to begin with. Evaluating 4 to the 1/2 power. Remember, a 1/2 power is a square root. I'm not going to rewrite it. We're just going to think of 4 to the 1/2 power as the square root of 4, which gives us 2. And those powers we need to add again. We've got multiplication, which means we add the exponents, 2/3 plus 3/7. Our common denominator is 21. Multiplying that first fraction by 7 and the second fraction by 3, our power is 23 over 21. We're going to take a look at simplifying roots again, and now that we know that roots are equal to rational exponents, it will help us get these in simplest form. Starting off with a factor tree for 128 to see if we have any perfect sixth roots of 128. I know 128 is 64 times 2. 64 is 8 times 8, and 8 is 2 times 2 times 2. Which gives us a perfect sixth right here. We have 2 to the 6th power. For our variable piece, what we're going to do is rewrite it as a rational exponent and bring the whole thing out from under the radical. Running out of room, so I'm going to go off to the right. We have a to the 8th, and I'm going to turn that root of 6th into a 1/6 power. Our power of a power rule is to multiply. So that gives us a to the 8/6 power, and 8/6 can be simplified to 4/3. So I'm going to pull a to the 4/3 power completely out of the radical. At this point, what I recognize is that if we pull that a out completely with a fractional exponent, we would still have this 2 left over under the radical. So we would be mixing a radical with a rational exponent. Those answers just don't look real clean. So what I'm going to do is rewrite 128 as 2 to the 7th power, and we'll simplify this with just rational exponents. Starting off with rewriting that 128 as 2 to the 7th power, remember we found 2 to the 6th power here, and we had a 2 left over for a total of 2 to the 7th, and a to the 8th to the 1/6 power. Distributing that power, we get 2 to the 7/6, and what we just saw off to the right was that simplified to 4/3. And finally, this looks like a big disaster, but we'll get it simplified. You have two options. We can simplify inside the parentheses and then take everything to the -2 power, or we can raise everything to the -2 power and then simplify. Because raising it to the -2 power would make those numbers bigger, I'm going to choose to simplify first and then raise it to the -2 power. Our m's, we have division, so we need to subtract those exponents. 5/6 minus 1/3, getting a common denominator of 6, would give us 5/6 minus 2/6 for a total of 3/6 or 1/2. Because the power on m was larger in the numerator, that's where our answer will go. For our n, we are going to bring that to the denominator to make the power positive, and then we will add because we'll have multiplication. 3/4 plus 1/3, common denominator of 12, 9/12 plus 4/12 gives us a total of 13/12. Again, that goes in the denominator because the n moved to the denominator. With that -2 power on the outside, we have two options. We can distribute it, make both powers negative when we multiply, and then flip them. Or we can take care of the negative sign first by flipping what's inside and then distributing the power of 2. So when you have a negative power, it flips everything. So this is one way that I find to be very quick to get rid of that negative exponent that was on the outside. Finally, distributing that 2, I'm going to use it to simplify with the denominator because both of my denominators are even. 2, simplifying with the 12 in the denominator on the end will give me a 6 in the denominator instead. And the 2/2 will give me a power of 1 on my m. If you are really not comfortable with fractions, I will show my work. 13/12 times 2, the 2 simplified with the 12 to become a 6, and of course 1/2 times 2 becomes 1. Here you have 2 U-try problems. Please attempt them because when you come to class, if you got them wrong, you will know how to fix your mistake. If you do not attempt these, then you have no idea how much you understood from this video.